Ever wondered what ions are in chemistry? If yes, then you're in the right place. Let's dive right in. In the realm of chemistry, an ion is simply an atom or molecule that has either gained or lost one or more electrons. This gain or loss results in a net charge, which can be either positive or negative. The charge is usually expressed as a superscript right next to the chemical symbol. Now, if an ion has a positive charge, we call it a cation. Some common examples are sodium, represented as Na+, or calcium, represented as Ca2+. On the other hand, if an ion carries a negative charge, we refer to it as an anion. Good examples include chloride or Cl and oxide or O2. So in essence, ions, whether they're cations or anions, play a significant role in the chemical world. Now you might be wondering how these ions were discovered. The discovery of ions is credited to the work of two brilliant scientists, Michael Faraday and Svante Arrhenius. In the year 1833, Faraday observed that electrolytes conducted electricity. But how did they do this? Well, it was through the movement of charged particles in a solution. Later, the concept of ions was further refined by Svante Arrhenius. He proposed the theory of ionic dissociation. This theory explains that some compounds, when dissolved in water or any other solvent, break down or dissociate into charged particles or ions. This phenomenon of breaking down into ions is what we call ionic dissociation. It's like a magic trick where a single entity splits into two, each carrying an opposite charge. So, thanks to Faraday's observations and Arrhenius's theory, we started to understand the existence and behavior of ions. And that's how the existence of ions came to be known. Ions are not all the same, they come in different types. Now let's delve into the three main types of ions: cations, anions, and polyatomic ions. First up, we have cations. These are ions that carry a net positive charge. This happens because they lose electrons. An easy way to remember this is to think of the T in cation as a plus sign. Some common examples of cations include sodium, which is symbolized as Na+, and calcium, represented as Ca2+. Next, we have anions. These are ions that have gained electrons, resulting in a net negative charge. If it helps, you can think of the N in anion as a negative sign. Chloride is a well-known example of an anion, and it's represented as Cl. Last but not least, we have polyatomic ions. These are a group of atoms that are covalently bonded, meaning they share electrons and have a net charge. They can be either positive or negative. Examples of polyatomic ions include carbonate, which is CO32, and ammonium, represented as NH4+. These different types of ions, each with their unique properties, play a vital role in the chemistry world. Their ability to gain or lose electrons, forming positive or negative charges, enables them to participate in a myriad of chemical reactions. These ions, with their unique properties, contribute to the diversity of chemical reactions. Did you know that ions also play a key role in surfactants, the stuff that makes your soap and detergents work? Surfactants, or surface active agents, are fascinating molecules with two distinct parts. One part is hydrophilic, or water-loving, while the other is hydrophobic, or water-repelling. These two contrasting parts allow surfactants to be effective in cleaning and forming foams. The ionic nature of a surfactant refers to the charge its hydrophilic head group carries in solution. There are four main types of surfactants: anionic, cationic, non-ionic, and amphoteric. Anionic surfactants have a negatively charged head group, while cationic surfactants have a positive one. Non-ionic surfactants don't have a formal charge, and amphoteric surfactants can exist as both anions and cations, depending on the pH of the solution. The ionic nature of surfactants influences their properties. For instance, ionic surfactants tend to have good water solubility due to the attraction between their charged head groups and water molecules. They also form micelles in solution, where the hydrophobic tails cluster together while their head groups interact with the water. The ionic nature can influence the critical micelle concentration, or the point at which these micelles form. It also affects the surfactant's foaming and wetting abilities, making ionic surfactants great at stabilizing air bubbles and lowering the surface tension of water. So the next time you wash your hands, remember the ions at work. The interaction between ions and pH is quite fascinating, especially in the case of surfactants. The ionic nature of surfactants, particularly the amphoteric ones, is quite an interesting story. These surfactants are like chameleons. They can change their ionic nature depending on the pH of the solution they're in. In an acidic environment, these amphoteric surfactants behave like good citizens. They act as cations. But change the environment to an alkaline one, and they transform, becoming anions. It's a fascinating dance of transformation driven by the conditions around them. But wait, there's more. The term virgin pH might sound a bit out of place in a chemistry discussion, but it's quite relevant here. The virgin pH of a surfactant, you see, refers to the pH of its aqueous solution without any other additives. It's like the surfactant's natural state, its baseline, if you will. And why is this virgin pH so important? Well, it gives us an indication of the dominant charge state of the surfactant in that solution. For instance, anionic surfactants, which have a negatively charged head group, usually have a slightly alkaline virgin pH, typically around 7.5 to 8.5. This alkaline nature is due to the presence of their negatively charged head groups. In summary, the ionic nature and pH of surfactants are closely intertwined. The pH of the solution can influence how a surfactant behaves, and the surfactant itself can influence the pH. It's a delicate balance, a dance of ions and pH, that helps surfactants do their job effectively. So there you have it. Ions, pH, surfactants. These aren't just isolated concepts, they're interconnected, each influencing and being influenced by the others. It's a dynamic, ever-changing world at the molecular level, and it's this dynamism, this interplay of ions, pH, and surfactants that gives us a deeper understanding of the marvel that is chemistry. Ions, pH, and surfactants, a dynamic trio that gives us a deeper understanding of chemistry. Let's wrap up what we've learned so far. Ions are atoms or molecules that gain or lose electrons, resulting in a net charge. Discovered by Michael Faraday and further developed by Svante Arrhenius, ions can be cations, anions, or polyatomic. In surfactants, these ions play a crucial role, influencing properties like solubility, micelle formation, foaming, and detergency. The ionic nature of surfactants even changes with the pH level. And there you have it. A comprehensive understanding of ions and chemistry. Until next time, keep exploring the world of chemistry.